and new advancements in the space. We can easily use dplyr with Spark, but have you dreamed of using Spark with tidyr? Well, this talk is also for you. So let's get this thing going. Javier?
All right, thank you so much, Ellis. And definitely be distracted the first few minutes. I just want to make sure that things are working, but definitely it's a first, as you were mentioning, but I'm super excited to be able to do this with the rest of the Multiverse team. And yeah, as you were saying, Ellis, we're going to split this talk between Pins and Spark. I'm going to get the first half of this talk where we introduce Pins and give some context. And then Yitao is going to join us remotely with the rest of the talk. And yeah, so, well, thank you so much. And just kind of like as just giving an overview, like why is this interesting, right? And especially why did we put Spark and Pins together on the same kind of like session? And just kind of like a really brief overview, one chart that I stole from the Mastering Spark with R book is that we all know from one way or another one that there's a lot of information and it's kind of like growing each year. And in this particular chart is just a chart from the world information kind of like growth, where it was estimated that it has surpassed like what is analog information, newspaper, books, and why not. So there's definitely this kind of need to process more information. And the way that we usually do that is what we have on the right side of the slide, which is we usually just dump this data into data centers, basically a bunch of computers. And then we usually have to do data science on top of them. One of the ways that we can do data science on those particular data centers is with tools like Spark that lets you basically process a bunch of information on top of, of basically your existing data centers. So that's going to be covered by the Spark talk. The other piece that I think it's also interesting mentioning is that a lot of times these data centers are managed by companies. And some of the companies that do work with these data centers are like Amazon. With tools like Amazon S3, you can upload your data sets to the cloud. Like you can also use Google Cloud, obviously, Microsoft Azure, and why not? So yeah, so there's definitely all these tools that you can use and to put your data sets in the cloud. But usually, up until today, it was kind of hard to put those data sets in the cloud. So again, what we're talking about today is two things. One, kind of like we're going to talk about the Sparkly R package, which allows us to use Spark from R, and that's going to be Yitao's talk. And then I'm going to talk a little bit about how to use the Pins package to get you to share data sets. And the Pins package is, supports multiple backends. So it's completely agnostic on what type of storage you store your data sets in. But the idea of the Pins package is kind of like make it a little bit more easy for you to transfer data sets to other people and also to storage locations. Like, like if you have a bunch of data on your local machine and then you want to share it with someone for someone to create an automated report or whatever, like you can use the Pins package to move your data set into, say, Amazon S3, or, like GitHub or RStudio Connect, DigitalOcean, Microsoft Azure, and why not? All right, so let's start first with Pins. And what I want to mention is that there's a very particular kind of like problem that I was trying to solve when the Pins package started. And here what I have is a few examples of things that kind of like have been bothering me for a few years. And, like, for instance, one of the things that I've noticed a lot is that we all use the Iris dataset a lot. And, even by looking at our bloggers, in this case, I think they were the post of June 16, I found out that, like a lot of the blog posts for that particular day, like use Iris, right? And we use Iris because it's, everyone has access to Iris, but then it asks the question is like, wait, is it hard to get other data sets? Well, maybe, right? And maybe that's why we get stuck on using Iris a lot of the times. Another type of problem that I noticed was that, whenever in this particular blog post, someone was just basically, assuming that the data is already on your local machine. So it kind of like was like, like it's pretty common to find like an R notebook file where, like there's a reference to a CSV file, but the CSV file is not on the actual report, right? And there's usually extra instructions to get you to download that file, and why not? And again, this is pretty it's pretty common to see these patterns also, like in many of the R blogs that we follow. And there's other cases where like some of the most kind of like, I would argue that best cases are where at least someone puts a comment on the R Markdown file or on the blog post on where to download the data from. So that's what we're seeing on the bottom, is like someone at least kind of like referenced the URL where the data lives. And then it's kind of like implied that if you want to rerun their particular data analysis, well, you would actually have to manually download it. So all these things are not terrible, but it does ask the question, like, can we do a little bit better than what we have today? And kind of like the answer here, or generalizing the problem a little bit more, is many of us have probably seen this diagram of what data science is. And usually data science, we kind of like explain it, and most precisely Hadley would explain it as it starts on import and finishes on sharing or communicating, and on communicating, I mean. But this is like the main kind of like use case for data science. But there's a few other tasks that we sometimes have to do it a little bit before or a little bit after. And some of them are, for instance, well, before you start importing your data, you usually have to download it to your local machine. You basically need to cache it, because that's what we all do when we're doing data science. I usually have to discover and figure out, like, okay, which data do I need to use? And even when you finish that particular data science project, even if you already built a Shiny app or an R Markdown document, at times there's like a post kind of like step where a colleague would ask you, like, hey, can you share that data source from the final project, because I want to reuse it to build something else. So that's what I'm calling sharing. And these three use cases, discover, share, and cache, are things that the pins package can help you with. And as part of that, as part of sharing your data sets in other platforms, you're kind of like growing, like the amount of data that you're sharing with your team, right? And then you can use tools like Spark and Why Not to process it if it ever gets to the point where you have too much data that you need to use more than one computer. So again, just kind of like as a recap, what is the pins package? Well, it's an R package that allows you to pin remote resources. Think about a pin as kind of like storing locally or storing remotely a piece of information. Usually this piece of information is a data frame, but if you're doing the, image analysis, you can also like store say a library of images for image recognition or whatever. You can also use pin find, which is a useful tool to discover what data sets are in your backend. And you can also share these resources, not just locally, but also you can use them on things like Kaggle, RStudio Connect, GitHub, Amazon S3, and many others. And yeah, we're currently on version 0.4.4. We consider that the project is maturing, and you're more than welcome to use it and download it from CRAN. And just to give a few examples on how the pins package can be used. The first use case is basically the pin and pin get verbs and pin find. And what we have here is a very simple use case. We're just saying we have the numbers 1 to 10. And basically what we want to do is store this particular data set just locally. And all you have to do to store this data set is basically just say pin, then your data set or your object, which in this case is just an array, it's not even a data frame, and you name it numbers. And basically what the pins package is doing behind the covers is just storing it in your local machine with a particular name, which is numbers. And then you can just retrieve it, right? And you say pin underscore get numbers, and that would retrieve you the R object that you store, which is the numbers 1 to 10. You can do a little bit more complex. You can pass to pin, instead of giving it an explicit numeric or R value or data frame, you can give it an actual file. So you can also ask pin, hey, store locally this file, or you can even tell it, as we're seeing in this slide, remote URL. So you can say, hey, this remote file that I have here, which happens to be a small version of ImageNet, download it and save it locally with the name tinyImageNet. So you run that, and then when you say pin get, you basically get the contents of this particular data set. Yeah, that's pretty much it. It's pretty straightforward. You basically, you're telling pin that by default, when you don't specify anything on pins, when you don't specify the destination, you're basically asking the pins package to store things locally, which is exactly what we're doing here. Now, where things get interesting is where you actually want to store the contents on a very specific location. And for that, the concept that we have is the concept of a board. And you can think about it as, you have different pins that you store, and then where you store them is your board. And you can have different boards, which are basically our backends. So you can have a backend, which is, first of all, your local file system, which is your local board that by default you get when using pins. But you can also get other particular boards like using DigitalOcean, Amazon S3, and why not. And the way that the way that this works is basically you register the board. So you need to say board register, and then you specify the board that you're registering to. This code is a little bit simplified. So for instance, if you were registering to S3, you would say board register S3 and then a comma, and then some parameters, right? Like the bucket, or I believe the bucket is required, and also the access key on S3 boards. When you use connect from RStudio, you just have to say board register and then say RStudio connect, which is quite easy. If you're using GitHub and you have your GitHub path file, then it's again pretty straightforward. All you have to do is say board register GitHub, and you would also have to set the branch and the repo. The branch could be by default set to main, but the repo you do have to specify. So again, there's some variation for each of the particular backends, but in general, you basically just say board register. And once you have these board registered, you can just, with the same ease of use, you can store those particular R objects. So we have here the same example where we're saying pin the numbers 1 to 10. But instead of, in this case, instead of assuming that things are going to get stored locally, we could specify the board and say board equals S3 or board equals RStudio Connect. And basically what pins is going to do is it's going to store this particular data set in whichever board you ask it to store. And then you can retrieve it and you can say pin get numbers, or you can be specific and say pin get numbers, comma, board equals S3, right? And same thing, you can do the same for a URL or for a local file. You can ask pins to store a particular file or a remote URL in a particular location, and then you can search for them. And kind of like one of the good things of having this approach is that we all love using open source tools that are decoupled from any particular proprietary service. So also, what the pins package allows you to do is kind of like very easily, if for some reason you had to switch between storage providers, right, and say, hey, I'm working with storage provider X and it's not working out, or maybe you want to lower costs or whatever. If you don't need to like rewrite all your code to use a different SDK or a different package to write to a different storage location. All you have to do is register a different board. And you would say like, hey, now I want to register to board Y, and your R code would still work. And not even that, but now you're also making this particular data set available to other people that can just go and download it. And for instance, when we store the data sets as, if you're storing a data frame, by default, what gets stored on the backend is the R object and also a CSV file. So if you were using GitHub, for instance, you can just very easily go to the GitHub page and pretty much just download the CSV file. If you want to learn more about pins, and you can go to pins.rstudio.com. And that's currently the best resource for learning everything that is there to know about pins. I know this, might be a lot to cover in just kind of like a short period of time, kind of like fully using a package. But like, for instance, if you were interested on learning, hey, how do I exactly use it with S3? You can find examples on pins.rstudio.com. Or if you were to be interested in GitHub, for instance, you can find kind of like the specific steps for doing that, and also some examples for getting you up and running. Some of the really interesting use cases, I think, you can, for instance, just to mention one, there's obviously multiple ones, but you can, for instance, use it on your Shiny apps to update the data set without having to update the full Shiny application. So, in this particular case, we're registering the board to be our Studio Connect to download that data from our Studio Connect. And then we have a Shiny app. It's a very simple Shiny app, but basically all it does is it reads a particular data set. In this case, the data set that we're reading with pin reactive would be kind of like a pin that is related to a news feed that we're perhaps auto-generating from like an RSS feed or whatever. And it's worth mentioning that this pin reactive function is basically the same as pin get, but the reactive format that is compatible with Shiny applications. So you basically, this particular pin would automatically update whenever the remote data set is updated. And one of the great things about using pins is that the data set is always queried before it gets retrieved. So if you have a remote data set and you re-need a markdown document, or if you have a Shiny applications with a reactive pin, the data set is not going to be downloaded all the time, but it's only going to be downloaded when it changes. And that's kind of like really useful, both when you're needing or when you're working offline or things like that, because you don't want to be re-downloading the data sets all the time, but you still want to have reproducible code that doesn't depend on manually downloading components. And I believe we have a preview of the app here. This is kind of like how it looks like. Again, it's not like a super interesting app per se. The interesting piece is how it's working behind the covers, which is mostly just a newsfeed that gets, as I was mentioning, it gets the data from our Studio Connect. All right, so with that, I'm going to switch tracks, and we're going to switch to Yitao. Let me just switch presentations, and we'll have time to kind of like learn a little bit more about Spark. And then the plan is mostly to close with questions.
Javier, I don't think we're getting audio.
So that everything is updated. Hello, in this video, I will give a...
There we go. Now we have some audio. If you want to make that a little bit louder.
Video and concerning the maintainer of dplyr. So in this presentation, I will start with an overview of Apache Spark and dplyr. I will run some simple demos of dplyr functionalities. I will also mention an excellent book about dplyr that is really available online. And after that, I will showcase some of the recent dplyr features that are not in this book yet. And I promise I will eventually make them out of this book so that everything is up to date. And finally, I will also talk about my personal view on the comparison between dplyr and dplyr, and just list some of the pros and cons from my point of view. So what is dplyr? dplyr is an R interface for Apache Spark. As many of you know, Apache Spark is a fairly powerful and popular in-memory distributed data analytics engine, which, let's just say, is something that approximates infinitely better than MapReduce. Because Apache Spark is mostly implemented in Scala, and many data scientists use R as the programming language of choice, Sparkly R has been created to work as a bridge from the world of R to the world of Spark. Sparkly R is available on CRAN, just like most R packages. So if we go to CRAN, we can see the most recent release of Sparkly R on CRAN was from version 1.4. I would say, well, okay, so because Sparkly R has been around for a while, it supports many versions of Spark. Earlier versions of Sparkly R supported Spark 1.6 all the way to Spark 2.x. And then recently, after Spark 3.0 was released, Sparkly R also started supporting Spark 3.0 shortly afterwards. I guess the best thing about Sparkly R is that it supports many R interfaces that are well established and well known among data scientists working with R. For example, you can find Sparkly R featured Room interface for extracting nice tabular summaries from many Spark ML models. There is the support for dplyr, a common R interface for database backends in R, and Sparkly R uses that very same interface for working with Spark connections. Sparkly R also supports the use of dplyr verbs for manipulating Spark data frames, so that there is no need for anyone to write non-SQL queries when querying data from Spark. And similarly, there is also the recent addition of tidyr support in Sparkly R, starting from Sparkly R 1.4. So tidyr verbs are fairly powerful constructs that allow data scientists to transform Spark data frames in non-trivial ways. All right. So next, I will talk about how to install Sparkly R. Well, because Sparkly R is available on CRAN, it's simply running install.packages. Sparkly R will fetch the latest version of it that's released to CRAN, which is fairly straightforward. Or alternatively, one can also run something like this to fetch any version of Sparkly R that is on GitHub, but it has not been necessarily released to CRAN yet. Next, I will show different ways of connecting to Apache Spark from Sparkly R. Well, there are many possible ways to do it depending on what you want to accomplish. For example, if you are just prototyping something locally, you can start Spark in local mode. So I will demonstrate this first. Actually, before I go ahead with this demonstration, I should mention if you have never installed any version of Spark on your machine before, the quickest way to install Spark is probably through this Spark install method. You simply need to specify which version of Spark you want to download, and it will take care of the rest. So, for example, if I were to run something like this, then afterwards I will find a version of Spark being downloaded onto this directory that's at my home directory /spark /spark version number. So yeah, that's why that's. So anyhow, because I've already run this previously, I will not run it again. And so to launch Spark locally and have Sparkly R connect to it, I will simply need to run something like this. and I should be able to find the a Spark process that is launched locally. So yeah, so that's it. So this is the Spark submit binary running, and you can see it has some default configurations, and then dplyr is submitting a Spark application, and by default, the name of the application will be dplyr. So yeah, all right. So now that we are equipped with the Spark connection, we can do many amazing things, such as creating a Spark data frame. I will just run this this method, which will create a Spark data frame consisting of one column of consecutive integers from 1 to 100. And to make this demo more interesting, I will partition this Spark data frame into 5 partitions. All right, we'll wait for it to complete. So for those of us who are not yet familiar with the concept of partitioning in Spark, a partition within a Spark data frame is, I would say, the minimum unit of parallelization for a Spark executor to work with. So say if we have 5 Spark executors in a Spark cluster, and we want to do something in parallel with this Spark data frame, then each executor will work on one partition at a time, and all partitions will be processed in parallel. All right, so back to this demo. So after we create a Spark data frame, we can do certain things such as using the pipe operator and to print the first 5 rows of this data frame, for example. And we can also do other things such as using dplyr to only fetch a subset of rows in this Spark data frame. For example, we can have a dplyr that will let's say we want to fetch all the odd ID numbers. So that would be this. And all right, I hope it works. All right, yeah, it works. And also, for example, we can run something like this. Yeah, something like this, just to confirm that our data frame has 5 partitions as expected. So next, I will repeat the same exercise on an actual Spark cluster. So people typically start connecting to a Spark cluster when they are done with their prototyping and they just want to deploy some algorithm at scale to multiple machines. So for this demo, I will use an EMR cluster. So first, I will have to log in to the driver node of that cluster. I have installed R on that host already. So next, I will well, obviously attach the dplyr package, and then I will need to talk with the I will need dplyr to talk with the cluster manager to allocate resource for the Spark application that is about to launch. In this case, the cluster manager is something named yet another resource negotiator, also known as yarn. So let's see. So I will specify the cluster manager is yarn, and the Spark home is I think something like this. We need to specify Spark home to help dplyr locate where the version the copy of Spark has been installed on this machine. So I think that's all we need. So let's see what happens. Also, in the meanwhile, I would like to show you I would like to show you all the Spark related processes that are already running on this machine. So the output is a bit difficult to read, but we can see, well, there is the name nodes, some process related to the name nodes, obviously, and there is the Spark history server, and finally, there is the resource manager for this entire Spark cluster, which dplyr is working with at the moment. All right, so let's close this, and then so now we shall do the same exercise of creating a Spark data frame. So in this case, this Spark data frame, if we were to partition it into 5 different partitions, it could be distributed among 5 different nodes. And then we can do the same. So for example, if I were to run a query such as this, then there could be multiple Spark workers working in parallel in all 5 partitions of my data frame. All right, great. So that's all demos I will have for connecting to Spark. Next, I would like to mention a book named Mastering Spark with R, which is freely available online, and it's written by my colleagues at RStudio. In my opinion, it's a really great book for getting started with dplyr. It contains a fairly detailed description of many aspects of dplyr, such as, among other things, building machine learning pipelines, working with all types of cluster technologies, and also creating and working with dplyr extensions, and also finally a chapter on how to work with streaming data in Spark. So yeah, I think it's a great book, and I promise I will keep it updated so that recent features of dplyr will be reflected in some of the chapters here. So that concludes the first half of my presentation. In the second half, I shall go through 2 simple demos, one about building a machine learning pipeline, and another about working with streaming data frames in dplyr. After that, I will briefly highlight some recent dplyr features and also talk about what I see as major differences between dplyr and SparkR. All right, so let's check out this ML demo in dplyr. In this demo, I will use a data set of Shakespearean plays downloaded from kaggle.com. The goal here is to build a model that can predict which characters said which sentence based on the words within that sentence. So first, I will show you what the data set looks like. So the data set is a JSP file that contains plays written by Shakespeare. It has a column specifying the name of the play and a column called Act Scene 9 that essentially has 3 integers in it concatenated together, which I will explain later on. And finally, there are 2 other columns containing the name of the character and some of the words said by that character within a speech. So by speech, I really mean a contiguous time duration during which one character is saying 1 or more sentences. So for example, here we can see there is this one character named King Henry, and there is a long speech going all the way from here to here within the first act of Henry IV, and yeah, he has said many sentences within this one speech. So one thing to notice is obviously a speech within this data set might be described by multiple rows, and in order for the machine learning model I'm building to be successful, I will need to group all those rows together and extract features from one speech at a time, rather than one sentence at a time. So yeah, so with that said, I will show you the script, the R script, and I have created for this demo. So I will explain pretty much every part of this script, starting from setting the pseudo-random seed for the current R session, so that everything determined by pseudo-random numbers within this script will be repeatable. Next, this is just reading the CSV file into a Spark data frame, and after that, as I have previously described, for this machine learning model to be successful, I think it's necessary to group all the rows containing the same speech together, and also, so here, after all the rows, all the groups of rows are identified, I'm applying a higher order function named aggregate to combine all the lines together. And so I should briefly mention that aggregate is one of the higher order functions in Spark SQL. And so in order for it to work, I need to tell it how the values within a given group of rows should be combined together by specifying essentially a combiner function. And here the combiner function is specified using the formula syntax in R, and it makes use of another built-in function called concat WS in Spark SQL that just combines two strings into one by putting some white space in between them. So yeah, that is all the pre-processing I did in this data set. And then next comes the fun part of the actual ML pipeline, which does some feature engineering, and also it chooses which ML model to use. So a pipeline is a pipeline essentially consists of a sequence of steps for transforming the data set into features, and then also it needs to specify, in case of a supervised machine learning task, it needs to specify which column is the label column, and then finally it needs to specify which model should be used. So because in this case the input I have mostly consisted of sentences in English, and first using the tokenizer feature in Apache Spark machine learning library to split sentences into arrays of words. So that's the tokenizer transformation, and after that I already have a potentially useful feature, which is the total number of words within the speech given by a character. And then after that, I will be looking at the term frequency distribution within the speech, and so that's what the hashing tree gives me. And also, I will be looking at bigrams within each speech. So here I'm extracting n-grams with n equals to 2. And then I will be looking at the frequency distribution of the bigrams as well. So, and finally, there is also this stop words removal feature in Apache Spark, which allows me to ignore stop words in English, for example, like the word or for at. So I will also make use of this, and then I will be looking at also the time frequencies and the distributions of diagrams with subports removed. And then finally, I'm combining all of the features I have built about into a single column called features, and using something called vector assembler in Spark. And then finally, I think I can choose any one of those machine learning models. For this demo, I will choose a random forest classifier. So yeah, so that's the pipeline, and I won't be running it while I'm recording this video, because running this pipeline on the entire training set is slightly time consuming, but I can show you what the output is from it. So here we have trained the model based on the training data, and then afterwards we can apply the model to the test data and see how many predictions were correct and how many were incorrect. So I think for this one, roughly a third of the predictions were correct, which is not too bad considering it's like a simple model without advanced knowledge about the English language, without any knowledge about the thought mind within a Shakespearean play, and also it's attempting to accomplish something that could be even challenging for humans as well. So yeah, I guess that's mission accomplished. Anyhow, I promised to have an ML demo. I did not make promise about the accuracy of the results. So I think, yeah, I guess that's mission accomplished. Okay, so I hope you enjoyed the ML demo in dplyr. Next, I'll run a demo of dplyr working with streaming data. So streaming is something that is useful when they need to process a potentially infinite sequence of events over time, such as, for example, events of users visiting a website, and they need to produce some output for other input events, and therefore for an infinite sequence of inputs, they could potentially have an infinite sequence of outputs. And this is precisely the scenario I will simulate in this demo. This is the link to the source code of my demo, by the way. So I will show you. Okay, so that's the source code. So what I have in this demo script is, first of all, a call to something named string generate test, which will produce a random string of CSV data and will store the generated CSV files into some temp directory. Each CSV file should have 100 random data points in it. After that, I'm calling another function named stream read CSV in dplyr to obtain the stream of CSV data and transport them into a streaming data frame in Spark. So what stream read CSV does is it will watch the list of CSV files in that temp directory. It will keep track of which files it has processed already, and it will read other newly created CSV files in the order they were generated within the stream. So then this demo also shows with a stream of data, we can run some transformations, such as by using the dplyr mutate and dplyr filter functionalities. And so we can transform one stream into another. And another takeaway is, well, obviously a stream needs to have a source and a sink. In this case, the sink is the memory sink in Spark, which is pretty much only useful for testing and demo type of scenarios, because it doesn't persist any of the data points. And last but not least, another thing you'll see in this demo is streaming data can be visualized using Shiny apps. And as you can imagine, that's quite exciting because if a shiny app can react to all sorts of fluctuations within a stream of data points, it can help data scientists visualize the trend of such data points within a short duration of time. So now I shall run this demo in RStudio.cloud. The reason is because I think it looks better when I run it there. So what I will do is to copy paste all of this and just wait for it to be ready. So as you can see, while the code is running, there will be a 10 over here that shows the number of records being processed per second by the source of the stream on the top half of this chart, and then the number of records being consumed per second by the sink in the bottom half. So remember, because they did some intermediate computations with this stream, these computations can impede the flow of those data points, although by only some negligible extent. And then we can see this in this visualization that pretty much all the data points were being processed as soon as they were generated, and that is evident from the symmetric shape of all the bars on this chart. All right, that was fun. Next, I'll briefly talk about some recent new features from SparkDR 1.2 and above. Recently, Javier and myself had the pleasure of collaborating with some Databricks engineers, and we created a feature named Databricks Connect. Well, obviously, most of the work there was done by folks from Databricks, but we are really happy that they are interested in introducing something new to SparkDR. Also in SparkDR 1.2, there were support for transporting list columns from R to Spark data frames and then from Spark back to R. And also there was the support for using Spark as for each parallel backend. So just similar to how, for example, a PSOC cluster can be used as for each backend. Now we can also use a Spark cluster as a parallel backend there as well. Then in SparkDR 1.3 and above, there were some major improvements that made dplyr work better with Spark. Most notably, one of them was support for higher order Spark SQL functions using the dplyr interface and also the formula syntax in R. For those who are unfamiliar with the term higher order functions, there are a number of built-in functions in Spark SQL, and some functions take at least one other function as their inputs, and then they apply the user-specified function to some Spark columns. So those are known as higher order functions, and one concrete example here is, say, in Spark 3 or above, one can sort an array column using a custom comparator. So let's say if I were to have a data frame with array columns in SparkDR, then I can pass it to this type of transformation using a pipe operator. And so this says call the array sort built-in function in Spark SQL with this function as the custom comparator, and the effect of it is larger elements will precede smaller elements after sorting, so all the arrays will be sorted into descending order within the array column. So that was the higher order function bit. And in SparkDR 1.3, and 1.4, there were also improvements to make all the dplyr sample methods support weighted sampling, and also make them support sampling with and without replacements on Spark data frames. I actually wrote a blog post on RStudio AI blog about how it was done. Well, there was quite a bit of mathematical details there, so I probably won't explain everything here. And also in SparkDR 1.4, there was the support for a number of dplyr verbs on Spark data frames, so that data scientists can transform data already in Spark, for example, to transform from the wider form to the longer form, or vice versa, or to have nesting or unnesting of dropped columns and things like that. So all of the implementations of tidyr verbs, they make use of efficient data transformation features provided by Spark, so that they perform for those tidyr transformations as fast as possible for data that is already in Spark. All right. Next, I'll talk about what I personally see as some pros and cons of SparkDR and SparkR. The short answer is both of them are great in different ways. From my point of view, SparkDR is simply something that is more closely integrated with the rest of the ecosystem in R, and is definitely more geared towards people already using R extensively for data science and who just want to leverage the high scalability of Spark while still having other familiar practices and constructs and interfaces from packages such as Room, dplyr, and recently tidyr as well. So moving on to SparkR. SparkR is a lightweight R binding for Apache Spark. Its release cycle is tied to Spark releases. That has been the case since a while ago. Because SparkR is more closely tied to Apache Spark, you'll see, for example, some very new cutting-edge sort of Spark functionalities being supported by SparkR first before they become available in SparkDR. So I guess that's a good thing. One slight downside I see about SparkR is because SparkR is not guaranteed to be available on CRAN. So say hypothetically, if I were working on some R package that needs to depend on SparkR, it cannot specify that dependency the same way it does for other R packages that are on CRAN. And also, it will be a bit awkward for people trying to install say the package I'm working on, but then they see this error message that says SparkR is not on CRAN, then that would be confusing, right? So anyhow, that's just my 2 cents on this topic. Finally, I would like to say a big thank you to the open source community, especially to people who have provided inspiration for some of the recent SparkDR developments, and also for those who have helped making SparkDR better. At the risk of stating the obvious, I will point out the best place to get help with SparkDR aside from Stack Overflow is through this tribe on GitHub. And also, obviously, as the maintainer of SparkDR, I will be really happy to see your pull requests in here, and I will review them to the best of my ability. That's all I have for this presentation. Thank you.
All right. So that was Yitao's presentation, and I really apologize to to anyone, well, mostly everyone that had to experience the kind of like audio issues. We'll definitely fix that for tomorrow's talk. And just to recap, there were a couple questions on the chat, and let me see if I can open that for us, and we'll just recap what we have. And let's see. All right, I was hearing some echo, but I think that should be fixed now. All right, so just to address some of the questions. The first one was if you can use pins with a network drive or network storage, and the answer there should be yes. It's just that you need to map the actual network drive to the basically your local file system. So if you're using Windows or whatever, you would have to basically map Windows to use that. Oh, actually, I know why there's here. I need to pause this. All right, so that should be better. Sorry about the echo. So I didn't realize that I was playing also the live stream while answering questions. So hopefully this should get rid of the echo. All right, yeah. So if you want to use pins with the actual network drive, you basically all you have to do is map the network drive to a local drive and then use pins with that. So that should work. And someone properly mentioned that you do that in Linux with mounts, and in Windows by using file mounts. And I think we had another question. Yeah, mounting. OneDrive is currently not supported with pins. However, one of the good news about pins is that there's a way of extending pins. So even though we might not have support for everything, when you go into the extending boards section, you can basically implement a particular like a particular definition of the API to support additional boards. So again, OneDrive is currently not supported, but it could be potentially also be extended. And for whoever asked that question, feel free to open a GitHub issue, and at least it helps us prioritize kind of like basically it helps us prioritize our features for the next release. And a few more questions. Yeah, so OneDrive is not supported. And I believe we also mentioned that we wanted to wrap up with talking about our Databricks Connect. So if you want more information about using Spark with Databricks Connect, I would recommend you go to spark.rstudio.com. And from there, what you can basically use is you can take a look at the deployment examples and then go to Databricks cluster. And there's different ways of using Databricks with sparklyr. The most common one is just to get an account with Databricks on databricks.com, and then just basically kind of like set up and use R the way that they recommend. So that would be one way of using Databricks with Spark and sparklyr. But the other way is connecting with Databricks remotely. And that's also another option. And basically, you would have to configure Databricks Connect the way that they specified, which is basically through a Python package, I believe. And yeah, once you have that kind of like running, the Python package running locally, then you can just connect through either R or RStudio through this component and use the remote Databricks cluster. All right, so I think we're kind of like on the dot, finishing up this up. And again, I want to really apologize to anyone that kind of like got issues. Oh, what about between performance with Spark R and sparklyr? Yeah, just to wrap up in this regard. So we still owe to kind of like present a side-by-side comparison between sparklyr and sparkr, or maybe the community wants to help us with that. However, sparklyr does support Arrow, Apache Arrow, which is another project that our studio supports. And we've seen like dramatically significant better performance when you use sparklyr and Arrow compared to sparkr. Now, I believe there's also a pull request and partially got added support for Arrow in sparkr. But this is something that we can definitely follow up. In my personal experience, sparklyr is as fast as sparkr. And mostly the reasoning is that sparklyr is making use of SQL queries under the covers while processing data sets. So really sparklyr is just as fast as the Spark SQL engine runs. And that's actually pretty fast. So yeah, I would say that, but I would definitely say that using sparklyr with Arrow is a huge improvement over just using bare bones sparkr. All right, well, thank you so much. I don't know, Ellis, if you want to do some closing remarks, or why not? And if not, definitely, if they want to join us tomorrow, I promise the audio will be so much better. And I again apologize for today.
Just wanted to say a quick thank you to everybody that stayed with us today to listen to both presentations. Javier, you did a great job. And I look forward to seeing everyone tomorrow, where we'll learn a little bit more about ML and Torch and what our studio has cooking with that.
Yep, looking forward to that. And honestly, looking forward to just being a little bit more connected with the community on these live streams once we figure them out. But thank you so much for everyone for attending. And bye, Ellis. Thanks for hosting this.
Yeah, no problem. Thank you.
All right.
Take care, everyone.
Bye.
Bye-bye.